Thank you again for the introduction. I am Paolo Madonia and I'm the product manager in AIKO. And today we are going to talk about one of our product, which is cloudyCHARLES, and how this software product, it's an onboard application, can improve Earth observation missions by filtering out data that turns out to be unprofitable. First, I'd like to say a few words about AIKO. I will already said a few things. We are a software house based in Italy, specifically in Turin, and we focus on delivery artificial intelligence solutions for the aerospace industry. So, so far we have already flew some of our products, and we have been involved in projects and activities in various domains, most notably Earth observation, telecommunications, and deep space. We have 3 products currently on the market, of which cloudyCHARLES is one of this group. And here we summarize briefly some of the major partnership that we have established throughout the last 5 years. AIKO has been founded in 2017. And our team currently accounts for about 28 people. Actually, we just hit 30, of which 25% hold a PhD degree. So I said that we deliver artificial intelligence solutions. We build products, software products, and we do so not in, let's say, unconnected way. We don't build tools that are separated from each other. We do so with an idea of an integrated ecosystem. So this software these pieces of software can work alone, but they work better if they collaborate with each other. They are deployed together. Specifically, we have three lines, let's say, of activity. The first one concerns smarter satellite operations, so most notably onboard software. That could be onboard artificial intelligence or onboard data processing. We have tools for the enhancement of human operators' activities on the ground. And finally, we are developing solutions to make the operations of constellations, and most notably mega constellations, more scalable. Today, we are going to focus on the first of these 3, let's say, lines of activities, that is the smarter satellite operations. And more specifically, we are going to talk about onboard data processing. So what cloudyCHARLES is a tool that is able to process and analyze data live on board of the spacecraft. So going back again, at this point, you probably have guessed that we are going to talk about Earth observation. And actually, before diving into the specifics of CHARLES, I'd like to touch a few points on the Earth observation sector, and specifically on the optical missions that are used in Earth observations. Thanks to optical satellites that are orbiting Earth, we are nowadays able to get pictures like this one. I would say pretty easily. They're quite common. It's quite easy also to download them. We got this one from ESA. This is a picture taken from Sentinel-2. And this shows actually an area close to our headquarters in Turin. You can spot Milan here in the bottom down of the image. You can see the Lake Maggiore here in the north. So a few years ago, pictures of this kind were almost incredible to see around, and now we are used to this kind of data. So they're really common. They are used in so many fields, from agriculture to infrastructure to logistics, maritime applications, aviation. So there, of course, defense. There's a large number of applications to optical imagery. And yeah, we get some beautiful views of our planet. Like here we see Rome, for example. Here's the city. Here down you can spot the airport. I know I'm probably biased and showing you just pictures of Italy, but yeah, I just wanted to show, you know, what beautiful data we can get nowadays with these assets in orbit. The level of detail that we get from optical satellites with different sensors, especially with multispectral or hyperspectral sensors that are capable of probing different wavelengths, it's incredible. However, by showing you this picture, I'm not telling the full story here. What we might get, in fact, is something like this. So the previous two pictures were pretty clean, but as Hywel was saying earlier on, in the UK has been raining forever now, and they've been covered by clouds most likely. And so that's what we could get if we were to randomly take a picture from the sky down at our planet. So the Earth is actually covered by clouds, and in this case, we were seeing a volcano in Southeast Asia. If we were interested in looking at the volcano, we would be fine, I would say, from this picture. But if we were interested in looking south of this mountain, we would not be able, because with this acquisition, our sight is hampered by the clouds in between. So yeah, our planet is covered in clouds, and it is so. Its surface it's covered by about 65% on average. So this is a picture from the Naval Observatory from the US. And this poses a problem for optical Earth observation. It is so because of clouds, we have to discard 30 to 40% of the data that we send down to Earth. And to better understand why this aspect is really a problem, I'd like to take 1 or 2 minutes to analyze the flow that usually is used and from acquisition to use of a data imagery product. So let's consider a generic Earth observation optical mission. We start, as I said, with the acquisition. Currently, we are located on the spacecraft. It's at the space segment level. And after this, the images are acquired, are taken. Once the satellite is inside of a ground station, this data is sent down to Earth. Now we send these data packets to Earth, and as you can imagine, in this data packet we can have some frames that are clean with a clear sky, some others that may be featuring clouds partially or completely with frames totally obscured by clouds. So in order to sell this data or distribute this data in case, for example, of the Sentinel missions that are open to the free access, we need to analyze this data and make sure that we are not going to distribute useless information. So once we get the images down to Earth, we analyze them, we keep just the good ones, and then we are able to distribute them. Now, you probably already spotted the issue is that we are doing this filtering down to Earth. Now, these would be, let's say, fine if the downlink wouldn't have a cost, but that's not the case. Downlink is actually quite expensive. And so having to download and spend money to get this data down to Earth and then discard it right away is a serious waste issue. Again, I remind you that we discard 30 to 40% of the data that we send down to Earth. So in terms of money, by looking at the data generated by the optical satellites And by looking at how many optical satellites are going to be orbiting the Earth over the next few years, we can get a glimpse of how much money is lost in this wasteful downlink activity. So in 2021, in the last few years, the estimates span from 30 million euros up to 70 million euros. And you can see that with the rising number of optical constellations in orbit, this number is set to rise quite highly over the next few years. So I believe that at this stage, at least I hope that the problem that we have to face is clear to everybody, and we are all on the same page. So I believe it's enough talking about the problem, and it's time to talk about the solution. So at AIKO, we developed cloudyCHARLES specifically to tackle this issue of the remote sensing market. cloudyCHARLES is an onboard software, as I mentioned already. And the technology behind it, it's deep learning. It has been conceived specifically for owners of Earth observation satellites. What cloudyCHARLES is trained to do, because deep learning is a technology that allows us to train machines to do specific tasks. What cloudyCHARLES is trained to do is to identify clouds in optical imagery data. So it takes as an input the frame that has been acquired by the spacecraft, by the optical system, process it, and then it outputs a cloud mask. Here you see cloudyCHARLES in action on a frame, and here at the bottom you can see the cloud mask. Thanks to this cloud mask, we are able to reconstruct, to calculate how what's the cloud coverage percentage in that frame, and depending on that number that we get, the spacecraft is then able to keep it or delete it. And so this actually is a decision that it's up to the end customer to choose what's the threshold value that he's fine with. So by using cloudyCHARLES, we are able to cut downlink costs because we are not sending down any more useless data, unprofitable data. And on the other hand, we are also able to provide actionable insights for onboard artificial intelligence agents, for example. So this is probably an extra feature, and I'm not gonna delve too much on this one during this talk. But if you recall that what I said at the beginning, at AIKO, we believe in providing solutions that are integrated. We could use the information extracted by cloudyCHARLES about the cloud coverage on one area, for example, to replan the mission on the go and avoid taking other acquisitions on the area as far as it's cloudy. One last point on this brief overview of CHARLES. I said it's been conceived for owners or operators of satellites, of Earth observation satellites, but on the other hand, it can also be deployed at payload level. So it can be a differentiator for payload providers, so that the optical system, the sensor, is able already to decide whether to keep an image or to discard it right away after the acquisition. So I want to go back for a sec to what we saw earlier. So that was the flow that I presented earlier on. We have the acquisition, we store all of this data, and we send it down to Earth, regardless of the quality of the data, because we don't know that already. And then after we analyze the data, we are able to keep only the good frames and distribute them. With cloudyCHARLES on board, what we can do is to analyze data right after the acquisition, so that when we get to the downlink phase, what we get down to Earth, it's only the good data. This has, of course, the first advantage that I mentioned, that allows to cut downlink costs, but a second advantage that I didn't mention so far is that also shortens the time to get access to the data. Not just because we are cutting this analysis phase on ground, but also because since we are downloading to Earth less data, we are getting access to that more quickly. Less passes over the ground stations are needed to get the hands on the data. So these are the two key improvements provided by cloudyCHARLES, and this is how the, let's say, the scenario of an Earth observation mission changes when this is used. So concerning the features of this product, the first one is the accuracy. With cloudyCHARLES, we are getting values of the F1 score above 90%. I'm gonna touch on that in a few moments when we get to the live demo of CHARLES. It is 100% software, as I said, and this has the first effect of being deployable on a variety of platforms. Now, we designed it to be compatible with several commercial off-the-shelf platforms, and I'm going to share with you the hardware compatibility specifications in a few slides, in a few minutes. Then by using a deep learning based approach, we are able to deploy cloudyCHARLES on different systems. It is payload agnostic. We can retrain the model to meet the specification of a given camera, of a given optical chain. So we provide flexibility in also towards the sensor and the instrumentation that is used to acquire the data. Lastly, it is pretty lightweight. It's on the order of a few megabytes. We're going to see that in a sec. And it's upgradable. So not just we can upgrade it and improve the model once it's in orbit, but we can also deploy it for the first time on satellites that are already in orbit. So there's no need, if you have already a satellite in orbit and you're thinking it's a pity that you're discovering this right now, no worries, we can also deploy it if your satellite is already there. Just a few words on the flight heritage. So the development of cloudyCHARLES started basically 3 years ago, and back then it was called Clarity. So that was let's say the prototype version of cloudyCHARLES. And when it was still called Clarity, we had a first flight with Satellogic, and back then we were among the first to run deep learning models, data processing models in orbit. And building on the positive results of that first flight, we continued the development throughout the years until 2022, until last year. And this culminated with the first release of cloudyCHARLES a few weeks ago. Now we are currently at the stage where we are launching officially cloudyCHARLES on the market. The first flight scheduled to occur in the first quarter, so in a few weeks you're going to be hearing more about this. And with an early access program that is going to start next month. With this program, we are going to provide discounted access to the product, and also we are going to provide extra support in training the model, in deploying the model on your platform. So if you're interested in knowing more about cloudyCHARLES and how this tool can improve your mission or save you costs, the early access program is probably the best time to approach this new technology. So at this stage, I probably showed you too many slides, so I'm gonna pause for a sec the presentation, and I'm gonna switch over a very brief demo of cloudyCHARLES. So I was saying, in this window, you're gonna see how what's behind, let's say, in a way, of cloudyCHARLES, and we're gonna test it with different boards that we have here at AIKO available. So enough talking, let's say. I'm just gonna take an image and explain you live with examples. So what you see here on the left is the image we are going to run cloudyCHARLES on, and on the right we have the ground truth mask, that's so-called ground truth. This is the, let's say, known position, known for sure position of the clouds in the frame, and we usually don't have that when we are processing data live in space on the platform, but we use the ground truth for training the model and also for validating the models after we train that. So in this case, this is a part of a data set that we use for training and validated CHARLES. We have the ground truth available, and the ground truth allows us to probe the performance, calculate the performance of our tool. So I'm going to start running CHARLES with the first of our boards. So here we have the Google Coral, and I'm gonna start from the bottom here. So what you see here in this interface, from the bottom we get the FPS, that's the frame per second that CHARLES is able to process. So the inference time was about 40 milliseconds. That means that at this speed it would be able to analyze about 20 to 25 images per second. The cloud coverage that is computed here is about 17%, which usually is deemed to be quite good. As far as you know, our customer have told us, a good threshold is usually between 60 to 50%. But that again depends strongly on the customer or on the application. So somebody could be fine with 70%, or somebody else could be fine with lower values. As you can see here, the F1 score is about just a bit lower than 90%. But this can depend on the platform that is used, because the model deployed on different platforms is optimized in different ways. So here we get a slightly lower F1 score. We get slightly, well, not slightly, we get a lower speed of inference with the Intel Myriad, which is not a surprise because it's less performant than the Google Coral. We can go over to the Jetson Nano. We get an FPS value which is halfway through the two previous boards, and we get an F1 score of about 86%, which is a bit worse again than the Coral. We can run this test again, for example, with a different image. This one is has more clouds in it. So here, for example, we get almost 92% of F1 score. Again, the Coral processes the image in about 40 milliseconds. So the Myriad here performs a bit better. So we also always have to take average values. As I mentioned earlier, the average performances that we are getting with CHARLES so far on different data sets has been above 90% of F1 score. So now that I showed you some of the performance of CHARLES, I'd like to show it like if it was in action. So I'm gonna select this full dataset. and I'm gonna select the cloud coverage threshold. So for the sake of this run, I'm gonna put it at 50. And by setting this parameter, we are going to get an information of how much data would be discarded on board. And so how much, let's say, how much money in percentage we could save in downlink expenses. So what you see here is a series of of acquisition, as if the satellite was hovering over an area and continuously acquiring images. Now you're going to see from time to time some of these squares to turning orange, and that's going to tell you when the cloud coverage threshold is exceeded. So this is happening here. And now it's happening also for the Jetson Nano. So the three, I haven't said that the 3 panels refer to the 3 boards that we are currently using. So the Coral and the Nano already finished. They were the fastest one, and the Myriad is currently still running. So while the Myriad finishes its acquisition, let's have a look at the numbers down here. So the data that were discarded according to the estimations made by the Coral were about 32% of data, whereas with the inference performed by the Nano, it was about 34%, so slightly higher value. And now the Myriad has finished, and also in this case we get 34%. If we were to use a different coverage threshold, then we can do that, of course. We would get slightly different values, well, slightly depending on how strong the difference is. So I'm just going to go with 60% here, around 60%. So running again the model. And as you can see, in this case, the Coral is running pretty steadily at about 23 FPS. The Nano is a bit slower, but you are going to see the 2 of them finishing basically at the same time. That's not an error. That's fine, because on one hand, the Coral is faster in performing the inference, so in understanding how many clouds there are in the frame, but the CPU that is paired to the hardware accelerator that performs the inference is less powerful in the case of the Coral. So we have a slight bottleneck in the processing of this information. So as you can see here, I used a higher threshold. So in this case, it was 61%, and of course we are getting a lower estimate for the data that would have been discarded on board. So yeah, this was just a very quick demo to show you the principles behind cloudyCHARLES and how this actually converts to a saving in the amount of data that is downlinked, and so in the costs that are related to this activity. These are not the only 3 platforms we can run cloudyCHARLES on. So at this stage, I'm going to stop again sharing my screen and switch over again to the presentation, so that we can talk a bit more about can you see the screen again? Okay, excellent. So I was going to say, we're going to talk a bit about the specifications that are needed in order to have cloudyCHARLES running. As I said, it's COTS compatible. So we have tested it so far with ARM architecture, both 32 and 64 bits, and also with x86 architecture. In terms of storage that is needed to host the model, And by using the floating point 32 model, we get a size of about 30 megabytes. That's a conservative estimate. It's slightly less than that. Charles runs on Linux-based operating system, and when it comes to memory, that's the value that mostly depends. That's, let's say, most volatile, because it depends on the libraries that are available. cloudyCHARLES would need from 20 to up to 320 megabytes of RAM available. Concerning the AI inference, so the actual operation of detecting the clouds, cloudyCHARLES needs a dedicated accelerator. Hosting, sorry, not hosting, and would need TensorFlow as a training framework. Also, the deep learning operators that are needed are the most common ones. So this is not, let's say, a specific requirement, but the list is quite long. So we can provide that in a separate occasion. And of course, if you're interested in using Charles, we are going to go through this list of operators that are needed. So when it comes to compatibility, we have tested it on the following hardware accelerators and on the following CPUs, but this list is currently evolving. So if the platform that you intend to use is not here, do not worry, because either we have tested it already and it's currently undergoing the final benchmarking, or if we haven't tested that already on your board, we can consider also exploring the compatibility of Charles on your hardware of choice. So concerning the activities that are needed from when you choose or you start to be interested in cloudyCHARLES until you actually use it in orbit, the first thing to do is to get some data from your system, from your platform, to train cloudyCHARLES. As I said, the product per se is platform agnostic, so that we can fine tune it to your platform. But to do so, we would need to get some training data from you. This way, our engineers would take care of this fine tuning. And also, on the other hand, our software engineers, by knowing the computational platform, so the hardware platform that we are going to run the software on, they will be able also to tailor the model and the product for the specific computational architecture. So these are the preliminary activities. When it comes to the deployment, we are going to run some tests, either on ground or during flight. We are gonna right after the deployment, of course, we are going to have a first commissioning time. And I like again that the software can be deployed either before the launch or after the launch has taken place. Last phase, so after the software has been commissioned, the nominal use phase starts. But of course, we offer software support to the users and also periodic checks on performance. So the fine tuning can proceed on, so that the best performance are guaranteed. And to do so, we provide the retraining of the model as needed. So at this stage, I lost track of the timer. So I will sorry if I was too too wordy on a few points, but we went to the end of this live demo today. So these are the 5 takeaway points that I'd like to highlight, and I'd like you to bring back with you after today's event. The 30 to 40% of data in optical mission is actually discarded after downlink, and this problem is going to cause quite large waste of money over the next few years, and it already has. For these, we at AIKO developed cloudyCHARLES, which will allow to filter out the data that turns out to be useless, and to do so directly on board, which is quite different to what is done today, as we saw. I'd like to remark again that CHARLES is completely a software product, so it's not tied to any hardware platform, and it is by design compatible with commercial off-the-shelf platforms. And just to close, I remind you that we are going to start an early access program in February. So if you're interested, again, I invite you to reach out to us, because that's the best time to approach this new technology. And if you have any questions that may pop up after this event, feel free to reach out to us at AIKO through this email, or through Narayan, and I will you can get to me and the CHARLES team quite easily. So thank you very much for being here today, and for this opportunity to Will, Narayan, and the satsearch team.
Fantastic. Thank you very much, Paolo. That was great. Really interesting to see the system in operation there, and I think everybody will have gained a lot from that. So yeah, wanted to thank you very much. We do just have a couple of minutes. Obviously, anybody who needs to go, please do. We respect your your schedules, of course. But yeah, if anybody can stick around, I just do have a few questions to put to you, Paolo, if that's okay. So firstly, one from somebody in the audience asked if the product works on L0 raw data, or does it need, for example, reflectance data in order to operate?
Okay, so the product, we tested it on a variety of data types and data products. Mm-hmm. So it is meant to work on L0 and L1 data usually. But again, the ultimate check needs to be done with the specific customer and platform. So to see how the model performs before the fine tuning and after the fine tuning. So in this sense, I invite the anonymous attendee who asked this to contact me or the team, and we can investigate their needs. Okay,
great. It relates a little bit to a question that we had actually. So we're tracking approximately 150 something different OBC systems in the industry today. Given that there are such a widespread variety of options for people, how do you work to ensure that the cloudyCHARLES can work with those different pieces of hardware?
So the goal for us is not to work with everything. Okay. I have to say, because that's, let's say, if you don't focus on something, you're not going to do that thing well.
Sure.
So far we targeted the let's say the most used platform, or at least the most promising platforms, and we intend also to hear the needs of the customers. So at this stage, we are still keeping an eye open to to new opportunities, but we are not running on every platform on the market, because that's not the point. We intend to be compatible, to provide flexibility, but we are going to evaluate this flexibility also on a let's say on a customer need basis.
Sure. Sure, absolutely.
Of course, the most sorry for interrupting you, but just to make this point more clear, in case of the most let's say used platform that we chose to run Charles first and test it on, but then if there's maybe some niche device that we didn't consider and that's not in our list, for example, probably we are not going to reach out to that device autonomously, but if somebody comes to us and asks if Charles can work on that, we can make it work. We can tailor it for that device. That's of course not 100% sure until we test it, but yeah, that's the plan.
Excellent. And then we've had a question from Marcia Walker about the early access program, just asking for a bit more information. We did discuss before the event that we can send out some more information to everybody who attended on that, but is there anything else you wanted to share about the program there, Paolo, at this point?
So we are going to release something. So you will be getting some news in that sense. Concerning the requirements is to have some kind of data product that you want to validate. Sorry, not validate. You want to run Charles on. So that's the only requirement. So if you have interest in doing some testing in, let's say, 5 years from now, to see how Charles works with your system, that's probably not the best occasion, because the early access program is meant to start over the next few weeks, and it should be lasting a few months. But if you have something to run Charles on in a shorter time scale, that's probably the best time to again pioneer this technology, I'd say. Yeah, I don't know if this answered the question from our attendee, but again, as I said, we are going to be making an announcement over the next few weeks. So if you will be looking on our channels or on our website, you will be hearing something about this. Excellent.
And yeah, as mentioned, we'll send a follow-up message for all the attendees or the registrants of this event, which will include some more information, or at least how you can contact Paolo there. So that's great. I think just, we are pretty much at time. So just a good final question perhaps to finish on is another one from Marcia. Why the name cloudyCHARLES? Obviously cloudy, but yeah. Why Charles?
Yeah. So that was I can imagine that the UK audience may see some connection with the recent development in the monarchy, but it's totally unrelated. Actually, cloudyCHARLES had this name before King Charles took the throne. So it's called cloudyCHARLES because we like to think our products as people. AIKO works with artificial intelligence, and we like to see these tools as intelligent as people can be. So all of our products have a name of a human name. So we have cloudyCHARLES, we have Speedy Skylar, and we have Orbital Oliver that are already on the market. We have a few upcoming products that will be released, but I'm not going to spoil their names today. So that's the funny, let's say, background about this choice.
Excellent. Well, I think that's a great place to finish up. As mentioned, we will be in touch further with everybody, and for example, Marcia, there in the Q&A, you've shared your contact details, etc., and we will follow up with you definitely. And yeah, thank you very much to Paolo for sharing all those insights and giving us the live demo of cloudyCHARLES in action there. And wanted to say thank you as well to everybody who was able to attend today. I think we're very grateful that people are, were willing to attend this sort of event early in January, and hopefully you got something out of it. I know we certainly did. We learned a lot about what can be done in terms of onboard data processing for Earth observation missions today in this really important area of the industry. So thank you again, Paolo.
Thank you very much for organizing this, and thanks to everybody who came.
Fantastic. Thank you, everybody. Have a great rest of the day.
Bye.
Bye.